Hello everyone, welcome to Pointer series part 2. In part 1, I have already covered the basic concept of pointers, how to declare and initialize the pointers, what do you mean by dereferencing operation, etc. You will find the link for the same in description box. Now in part 2, I will cover pointer arithmetic operations. Now we will see what are the valid operations on pointers. We can increment or decrement pointer. We can add constant value or subtract constant value from a pointer. We can also subtract or compare two pointers if they are pointing to same array or of same type. We will also find here which operations are not possible on pointers. We will see now first operation, increment a pointer. Pointer arithmetic is somewhat different from arithmetic operations that we perform on normal variable. All pointer arithmetic is performed according to relative size of base type of pointer. Now what do you mean by this statement? I will explain with example. Now suppose I declare integer variable I having value 20. Declare a pointer ptr of type integer. Now initialize the pointer with address of I. Here you will find I contains value 20 having address 1000. Now ptr contains the address of I, it is 1000. In case of normal variable, if we increment I, we will get the value 21. But in case of pointer, when we increment the pointer, it will point 4 bytes ahead from the current location. Means it will contain 1004 after incrementing. Because why? PTR contains the address of integer variable. And integer variable requires 4 bytes of memory for storage. Here I am assuming here 32-bit compiler. That's why 4 bytes. Means variable I requires memory location from 1000 to 1003. In case of 16-bit compiler, it will require 2 bytes. So pointer will be incremented 2 bytes ahead. Similarly, if the pointer is of float type, it will be incremented by 4 bytes. If the pointer is of character type, it will be incremented by 1 byte ahead. If the pointer is of type double, it will be incremented by 8 bytes ahead. Now we can set up the formula to find the new address, equal to current address plus 1 into size of the type of the pointer. Now in case of ptr plus plus, means ptr plus 1, ptr contains the address 1000 plus 1 into size of int, with 1 into 4, means ptr contains 1004. Let us see now C program. Here I am declaring two variables, one variable integer a having value 10 and pointer to integer ptr. Second variable is of double type having value 2.5 and pointer qtr to double type. So ptr contains address of A, qtr contains address of B. Now I am here printing original value of A, what ptr contains, the value at ptr. Let ptr increment. After incrementing, I am printing here the value, what value contains at ptr. Similarly, I am printing B as well as value, what value will be at qtr, and after incrementing what value qtr contains. Let us run this program. Let us see output here. Repeat A value contains 10 and ptr contains 628 here. And the value at address is 10. After incrementing, a ptr contains 632. This pointer ptr is move ahead 4 bytes. Similarly, you can find here qtr contains address 616. And after incrementing, it contains 624. Means qtr is move ahead 8 bytes. Now, let us move to second operation, decrement a pointer. As we can increment a pointer in the same manner, we can decrement a pointer. When we decrement a pointer, it will point to previous location. Now consider same example. Here I declare a variable I having value 20. Declare a pointer ptr, pointer to integer. Initialize pointer with address of I. So I variable having value 20 having address 1000. ptr contains the address of I, is 1000. Now when ptr is decremented, it will move backward 4 bytes from the current location. So it contains the address 996. As I have already explained, integer requires 4 bytes. So ptr will move backward by 4 bytes. Similarly, float pointer. In case of float pointer also, it will move backward 4 bytes from the current location. If the pointer is of type char, it will move backward by 1 byte. If the pointer is of type double, it will move backward by 8 bytes. So we can set up the formula new address value equal to current address minus 1 into size of type of the pointer. So PTR minus post decrement, PTR minus 1, 1000 minus 1 of size of int. So 1000 minus 1 into 4, it will contain 996. Let us see now C program for the same. Here I declare a variable a having value 10, declare a pointer PTR pointer to integer. Initialize the pointer with address of a. Now here I am printing the value of a as well as what PTR contains, as well as after dereferencing what PTR will contain. Now decrement the pointer PTR by 1. Now after decrementing, again I am printing what address PTR contains. Students, here note that after decrementing, PTR will not point to now original variable a. It will point to new address and it will contain new value. Just check the output. Now here you can check the output. Variable a contains the value 10. PTR contains the address. Last numbers are 632. And PTR contains the address. PTR contains the value 10. It points to a variable. After decrementing, you can find here last digits are 628. Means PTR pointer is moved backward by 4 bytes. Now here you can note, you can find that PTR will point to, PTR contains now 0 value. It will not point to original variable a after decrementing. Now third operation, addition of constant value to pointer. I will explain this example with the help of the array. Suppose I declare an array of 5 elements, a of 5, and initialize with the value 1, 2, 3, 4, 5. You can see here in the figure 1, 2, 3, 4, 5 and a having the address 1000. Now I declare a pointer to integer and initialize with the address of a. Here a name itself gives the base address, or you can write PTR equal to address of a of 0. The PTR is pointing to base location of array, it is 1000. Now if I add constant value 3 in a pointer, what will happen? Means pointer will move in forward direction 3 numbers ahead. Now one integer number requires 4 bytes. So 3 into size of int will be what? 12. So pointer will move from the current location 12 bytes ahead. So now PTR will point to location a of 3, that is the value 4. This PTR contains the address 1012. So we can find the new address by using formula new address equal to address in the pointer plus constant value into size of type. Size of type means int here. If pointer is suppose double type, it will move the pointer 3 into 8 means 24 bytes ahead. Similarly, we can subtract constant value from a pointer. Consider again the same example, but here I initialize the pointer now with address of fourth element of the array, means a of 3. A of 0 is the first element and a of 3 is the fourth element of the array. Means pointer now pointing to location 1012. Now if I subtract the value 3 from the pointer, what will we get? Now 3 means it will move the pointer backward by 3 numbers. So 1012 minus 3 into size of int. Means 1012 minus 12, it will give you what? 1000. The PTR will now point to first location 1000. So we can find the new address by using the formula address in the pointer minus constant value into size of int here. Size of type of the pointer. Let us see now C program for the same. Now here I declare a integer array a of 5 elements and initialize with the 1, 2, 3, 4, 5. I declare 2 pointers PTR1 and PTR2 to integer. So PTR1 is initialized with the base address of a. Here I am printing the PTR1 and asterisk PTR1. Now I added constant 3 value in PTR1. Again I am printing the what address will contain PTR in the PTR1. Also value stored at PTR1. Now pointer PTR2 is initialized with the address of a of 3, means fourth element of the array. Now again I am printing what address at PTR1 and PTR2 and what is the value stored at asterisk PTR2. Now subtract constant value 3 from the PTR2. After subtracting, again I am printing the address stored at PTR2 and asterisk PTR2. Let us run the program. Now in output, you can find that PTR1 contains 12, 612 in last digit, and PTR1 contains the value 1. Now after adding 3 in PTR1, it contains 624. Means PTR1 move ahead 12 bytes from the original position. Now it will contain new value 4. Now in PTR2, you can find the address 624 and PTR2 is pointing to value 4. So after subtracting 3, PTR2 contains 612. Means PTR2 is moved backward by 12 bytes and new value pointing is what? PTR2 contains what? 1. Now next operation is subtraction of 2 pointers. One pointer variable can be subtracted from other pointer variable if they are of same type and they point to same array. Consider same example again. Here I am declaring array of 5 elements initialized with the 1, 2, 3, 4, 5. Here I am declaring 2 pointer variables PTR1 and PTR2. PTR1 is pointing to base location with 1000 and PTR2 initialized with the address of A of 3. PTR2 is pointing to 1012. Here PTR2 is 3 numbers apart from PTR1. Subtracting of 2 pointer gives how many elements are between them or indicates how apart they are from each other. So PTR2 minus PTR1 will give how many elements are between them. 1012 minus 1000 divided by size of type. 12 divided by 4 means 3. Means PTR2 is 3 elements apart from PTR1. Let us see C program for subtraction of 2 pointers. Here I declare array A of 5 elements. Declare 2 pointers PTR and QTR. PTR initialized with address of A of 3 means PTR means A of 3 contains 4 and QTR initialized with the base address A. Now here I am printing the values of PTR and QTR. What address contains PTR and QTR. Now after subtracting what value we will get, we will check by running the program. Here in output, you will find that PTR contains 624 in address, last digits, and PTR contains 4. QTR contains 612 and QTR point to first element of the array 1. Now after subtraction, it will give the value 3. Means PTR is 3 elements apart from the QTR. Now next operation is comparison of 2 pointers. Like subtraction, we can compare 2 pointers if they are of same type and they are pointing to same array. All relational operators can be applied for comparing 2 pointers. The operators equal to and not equal to can be used to find whether 2 pointers contain same address or not. 2 pointers will be equal if both pointers are null or they contain same address of the variable. Now let us find which arithmetic operations cannot be possible on pointers. We cannot add, multiply, divide 2 pointers. Means P1 plus P2, P1 multiplied by P2, P1 divided by P2 is not possible. Also, we cannot multiply any constant value with the pointer. Means P1 into 100 is not possible. Similarly, we cannot divide pointer by any number. Means P1 divided by 100 is not possible. Also, we cannot add float value or double value into pointer. Means P1 plus 100.5 is not possible. Now why? Pointer stores the address and above operations may lead to an illegal address after addition or after division, which may not exist in the memory. So we should avoid this operation. But after dereferencing pointers, following operation can be possible. So after dereferencing, we can add P1 and P2. Means we can add value stored at P1 as well as value stored at P2. We can multiply P1, asterisk P1 multiply by asterisk P2. We can divide asterisk P1 divided by asterisk P2. Because why? These operations are deal with the values, not on the address. Let us see C program for the same. Now here I am declaring 2 variables, A having value 10, B having value 20. Now I declare 2 pointers P1 and P2 pointer to integers. Now P1 initialized with the address of A, P2 initialized with the address of B. Now I am printing here after dereferencing asterisk P1 plus asterisk P2. I'm printing subtraction of asterisk P1 minus asterisk P2. Also, I'm printing asterisk P1 multiplied by constant value 2. Let us run this program and check the output. Now here you can find the output. After applying dereferencing operation, so asterisk P1 plus asterisk P2 gives 30. It will give us a subtraction, the minus 10 value. Also, we can multiply asterisk P1 multiplied by constant value 2. That is 20. It will give 20. Means applying dereferencing operation, value stored at addresses can be multiplied, subtracted, or added. I hope you understand the concept properly. Thank you for watching the video. If you like the video, please subscribe my channel. Thank you.